So good morning everyone. Today I am going to present hyperconjugation. So let's start. Hyperconjugation is nothing but a delocalization of sigma electron of carbon hydrogen sigma bond of any alkyl group directly attached to unsaturated system and with unshared p orbital of a carbon atom. So this phenomenon is called hyperconjugation. You can see here, this is carbon, this is hydrogen, this is carbon, and this sigma bond, carbon hydrogen and vacant p orbital of this carbon form for hyperconjugation. So hyperconjugation, also known as no bond resonance and Baker-Nathan effect. So number of hyperconjugated structure is equal to number of alpha hydrogen and sp3 hybridized carbon atom. It is distant, independent, and it is a permanent effect. These two are the most important point. For hyperconjugation, you can see here. So I am going to present hyperconjugation in fastest carbocation. So this is called alpha carbon, this is called alpha hydrogen. So basically delocalization of this carbon hydrogen sigma electron to here to form so this is an hyperconjugated structure for this hydrogen. You can find for this hydrogen another structure for this hydrogen, carbon hydrogen sigma bond, another hyperconjugated structure. So here I can find 3 alpha hydrogen and 3 hyperconjugation structure will be formed here. Now case 2, free radical. This is free radical. So delocalization of this carbon hydrogen sigma bond to here to form hyperconjugation. So this is for free radical. You can find for this hydrogen, for this hydrogen. So totally 3 hyperconjugated structure will be formed here. For alkene, structure for alkene, hyperconjugation structure for alkene. So now the application of hyperconjugation. Hyperconjugation is determined for the stability of alkene. So number of hyperconjugation structure will be formed or the formation depend on the alpha hydrogen. So the stability of the stability of alkene depend on the alpha hydrogen. Number of alpha hydrogen will be greater the number of alpha hydrogen, greater will be the stability of alkene. Greater the number of alpha hydrogen, greater will be the stability of heat of hydrogenation. Again, the stability of carbocation, same. Greater the number of alpha hydrogen, greater will be the stability of carbocation. And free radical finally, greater the number of alpha hydrogen, greater will be the stability. So in hyperconjugation, the game will play alpha hydrogen. So next slide. Thank you so much for my presentation.